So what is the note that lies a perfect fifth above C, or a major third above A, or a minor sixth above F? If you're a musician, then these are all questions that you should be able to answer pretty confidently and quickly. And if you can't, then this video is for you. I titled it, How the Bleep Do Intervals Work, because I figured that this is a question that probably comes up in the minds of a lot of musicians pretty regularly. And my goal in this video is to clear up a lot of that confusion about how intervals work, how they're defined, and how they're named. And this is important if you're a musician because intervals are really the building blocks of all larger structures in music theory, especially chords, okay? So the first thing to understand about an interval is simply that an interval is a distance between two notes. So if I have a C and an F, let's say the F above the C, right? Then the distance between those two notes has a particular name, okay? And we'll talk about the naming of intervals a little bit later, but just for now understand that an interval is the distance between these two notes. And to understand some important points about intervals, we can think about some other situations where we would talk about distances. So for example, let's say I'm standing here and my friend Bob is standing some distance away from me, right? Well, we could measure exactly how far that distance is, right? Let's say it's just 8 feet, right? Well, here's a couple things to notice about that measurement. First of all, it doesn't matter whether I'm holding the tape measure or Bob's holding the tape measure. The distance is going to be the same either way, right? It doesn't matter whether we measure from me to Bob or from Bob to me. The distance is going to be 8 feet either way, right? The second thing to notice is that we've just taken this distance and we have this expression, 8 feet, to basically describe how large that distance is, right? We have feet, which is this unit that we've all agreed we know what that means. And then we have a number, 8, that describes how many feet we're dealing with, right? So intervals don't work exactly the same way as that, but they actually work in pretty similar ways, and we'll talk about that in just a second. Before we talk about that, though, let's look at one important point about intervals that we should really be aware of right from the very start. I'm going to draw a little staff over here. That's my best attempt at a staff and a treble clef, okay? So let's say this C is this note right here, and the F is this note right up here, right? Well, this is a good way of visualizing the fact that the distance between the C and the F, when measured from the C up to the F, is the same as the distance from the F to the C when measured from the F down to the C. That, whether we're measuring up or down, doesn't change the length of the distance or the length of that interval. However, if I were to take this F that we put here on the top line of the treble clef, and I were to move it down an octave and put it down here instead, then this distance now is a different distance, right? So the distance now from an F to a C when the F is below the C is different than the distance from an F to a C when the F is above the C, okay? So if we called this interval A and this interval B, basically just A does not equal B in this case. When we do this, this is called inverting an interval, taking one note of the interval and changing the octave that it's in. So you kind of leapfrog the other note and put it on the other side, right? And when you invert an interval, it changes the interval. So basically, what we've learned so far is that an interval is a distance between two notes like C and F, and just like a distance between two people standing on a street, whether we measure from C to F or from F to C, the name of that interval and the interval itself is the same. But if we leapfrog that note and we put it in a different octave or invert it, then that's going to change the distance between those two notes, right? So you always have to think with intervals whether the note, like whether this F is above that C, as in this case, or whether that F is below the C, as in this case, okay? So a good way to visualize intervals is by using a staff like this. And this way you can actually see visually that the distance between these two is different than the distance between those two. And you can also visualize that just on a keyboard. If you have a keyboard handy, you can see that the distance between the F above C and the F below C and that same C is a different distance, okay? So now that we understand a little bit about just what an interval is, right? That it's a distance between two notes. I've written here on the screen 3 names of intervals. And I just want to point out something about the naming system that we have here. Notice, if I put a little dotted line right here, we can sort of divide all of these names up into 2 parts, right? We have like a number over here, right? 3rd, 2nd, 5th. By the way, that's not a sharp sign. That's a number, right? So we have 3rd, 2nd, 5th, or the numerical description of an interval. And then we have over here a descriptor of the interval, major, minor, perfect. So sometimes we call this the quality of the interval or the type of the interval. So what this implies is that we could have a third that is not major. We could have another descriptor for this third. That also implies that we could have a major second or a major sixth. So basically we have descriptors that can be applied to different numerical intervals, right? So here I'll write up here that this is the quality of the interval, and this is the numerical description of the interval, whether it's a third, a second, a fifth, or whatever, okay? So now let's talk about where those terms come from and how we can understand them and use them. Okay, so I've written here what we call the C major scale, right? So this is basically just the alphabet from A through G, but I've started it on C and then gone up to C, right? And the reason I've done it this way is because the early keyboards, this is way back before the piano was actually even invented, even before the harpsichord. Early keyboards only had white keys, essentially, right? They were set up like this: C, D, E, F, G, A, B, C. So just like you took your piano, if you were to take your piano and just play the white keys from C to C without any black keys, that was how the early keyboards were set up. And the setup of those early keyboards has informed the way that we name intervals even today, okay? So it's a matter of tradition and convention. So as the early composers and music theorists were sort of talking about this scale, they numbered these notes from 1 all the way up to 7, and then we have the C on top just for good measure to round out the scale, so we'll call that 8, okay? And as they were describing the different notes of this scale, they would have said something like, all right, so D is the 2nd note of the scale, E is the 3rd note of the scale, F is the 4th note of the scale, etc., right? So over time, the interval or the distance from C to D became known as a second, simply because D is the 2nd note of that scale. The interval from C to E became known as a third, because E is the 3rd note of the scale, etc., all the way on up. C to F is known as a 4th. C to G would be a 5th. C to A, so ... C to A would be a 6th. C to B would be a 7th. And C to C would be, well, an 8th. We actually call that an octave. There's a special name for that interval called an octave, but it makes sense because oct is the Greek prefix for the number 8, okay? So now we have some understanding of where that numeric component of the interval name comes in, right? And if we look at C to D, C to E, and C to F, just as examples, let's look at C to D first. How many letters are contained within that interval? Well, we have a C and a D. So we have 2 letters, therefore it's a second. We have a C, a D, and an E. 3 letters, that's a third. C, D, E, F, 4 letters, that's a 4th. So essentially the numerical name of the interval simply comes from how many alphabetical steps it takes to get from the first note to the last note, or how many alphabetical steps are contained in that interval. And when you think about the numeric name of the interval, the sharps, whether there's sharps or flats in the interval, it doesn't really matter at all, right? So for example, a C sharp to an F would still be considered a fourth. Or let's say a C to an E flat would still be considered a third. Okay? So you ignore the sharps and flats and you just count the number of alphabetical steps in that interval. The second thing that we need to know about this, and I'm going to erase this so we can visualize this. The second thing that we need to know about this alphabetical naming system is that we don't necessarily have to start from C. We can start from any letter and go to any letter, and the number of alphabetical steps it takes to get there becomes the numerical name of the interval. So let's look at a few examples of that. If we go from D to A, well, let's see, how many alphabetical steps does it take to get there? D, E, F, G, A. How many? 1, 2, 3, 4, 5. So that interval is a fifth. Let's do another one, this one with some accidentals, because like I said, it doesn't matter which accidentals are present. You still just count the number of alphabetical steps, and that tells you what the numerical name of the interval is. So let's do, for example, an A flat to a D flat. Well, we have A, B, C, and D. From A to D, there are 1, 2, 3, 4 alphabetical steps. We disregard the flats, and that gives us a numerical interval definition of a fourth. Okay? So you can do this with any interval, any sequence of letters, and in fact, let's just do one more for good measure, okay? So here we have F sharp, why not? Let's put another accidental in there, up to B. Okay? So F sharp up to B, ignore the sharp. How many alphabetical steps does it take to get up to B? F, G, A, B. So once again, this interval is an interval of a fourth. Okay? So hopefully that explains how we determine the numerical definition or the numerical name of an interval. So now, if you think back to our chart of the interval names, we still have to worry about the left side of that chart, the major, minor, perfect, the descriptor or the quality of that interval. Okay? So in order to do that, let's write our C major scale up here again at the top. Okay? So C major scale is, as we all hopefully know, C, D, E, F, G, A, B, and we round it off with one more C. Okay? So, because the conventions for naming intervals developed when the C major scale was pretty much, the only game in town, or it was the most important scale for sure. The names or the descriptors that we give for the quality of intervals are based on the C major scale. So I'm going to make a little chart down here. Okay? And on one side of the chart, we're going to put the intervals that these guys way back in the day considered to be especially pleasing to the ear, right? They found these intervals to be especially harmonious or consonant or whatever words you want to use to describe it. And these intervals were the fourth, so the C to the F, the fifth, so the C to the G, and the octave, so the C all the way up to the other C, right? So the fourth, the fifth, and the octave were considered to be especially pleasing to the ear, or the fourth, the fifth, and the octave in this particular scale. And because, religion and music were sort of intertwined at this time, and things that were harmonious or pleasing were considered to be divine or godly, and the divine was considered perfect, they called these intervals perfect intervals. Okay? And I'm leaving space on either side of this perfect for reasons that you'll see in just a second. So they called the intervals, the fourth, the fifth, and the octave that are contained within the C major scale, those were defined as the perfect fourth, the perfect fifth, and the perfect octave, right? So any other types of fourths, fifths, and octaves were going to be measured against this perfect fourth, fifth, and octave contained within that C major scale. And then on the other side, the intervals that were not considered perfect, well, they were still part of the C major scale, right? And though they included the third, the second, the third, the sixth, and the seventh. And these intervals were not considered perfect because they didn't have that especially harmonious ring of these other intervals. However, they were still part of the C major scale. So they called these intervals the major intervals. Makes sense. Because now the major third, or the definition of a major third, is the third that's contained in the C major scale. The definition of the major second is the second that's contained in the C major scale, etc., right? So now that we have sort of a yardstick against which we can measure the lengths of different types of thirds or seconds or fourths or fifths or whatever, then we can start to combine these descriptors with the numerical intervals, right? So let's say we have I'm going to go down here so we have a little extra room to write. Okay, so let's say we know that the interval between C and E is numerically called a third, and we know that it's called a major third because it's the interval that is found in the C major scale. Well, in addition to counting the number of letters or alphabetical steps that it takes to get to the E from the C, we can also count the number of chromatic steps from C to E. And hopefully you're aware that black keys on the piano can be named either sharps or flats. Both names mean the same thing. Just for the sake of simplicity, I'm just going to use the sharp designation here. So the next step chromatically would be C sharp. Then we have D. Then we have D sharp. And then finally we have E. So how many chromatic steps did it take to get there? Well, 1, 2, 3, 4. So that's 4 chromatic steps, or more properly put, 4 half steps, right? So the interval from C to E that contains 4 half steps is called a major third, right? So basically, what does that name tell us? It tells us that the interval contains 3 alphabetical steps, if you disregard the accidentals, from C to D to E, and that the interval contains 4 half steps counting upwards from C. Okay? So you can do this with any one of the intervals of the scale. You could basically look at the second and you could define that as the interval that has 2 alphabetical steps in it and X number of half steps in it. It happens to be 2 half steps, right? And we could go through and define the number of half steps in a perfect fourth, a perfect fifth, a perfect octave, and a major second, a major third, a major sixth, and a major seventh, right? So now that we have kind of a yardstick that we can measure against, what would happen if we shortened that interval by 1/2 step? So on this side, I'm going to say minus 1/2 step. And when I say minus 1/2 step, what I mean is that as we go down the chart this way, we're going to be shortening the interval or making the interval smaller by 1/2 step at each step on the chart. Okay? So if we take a major third and we make that interval 1/2 step smaller, right? So instead of a C to an E, that's 4/2 steps, what we would have to do is we'd have to reduce that interval to 3/2 steps by making this an E flat instead. So I'm going to cross this D sharp out, and I'm going to make this an E flat. And what that means is now we have only we have only 1, 2, 3 steps to get to the E flat. So now instead of 4/2 steps, we have 3/2 steps, right? So it's still a third because if we ignore the accidental, we have 3 alphabetical steps, C, D, E, but we've shortened that interval by flatting the E, okay? We've shortened it from 4/2 steps to 3/2 steps. And when we shorten a major interval by 1/2 step, we call it a minor interval, okay? If we were to lengthen the major interval by 1/2 step, so I'm going to erase this stuff down here. So we can demonstrate what this is going to look like. So if we were to take a major interval like C to E, again, we know it's a third because of the number of alphabetical steps in that interval. But if we were to take this interval and lengthen it by a third, we could make this an E sharp, right? Now, I know an E sharp is kind of a weird thing because E sharp and F are enharmonically equivalent, but for the purposes of our discussion here, this is what we're going to do. We're going to take a major third and we're going to lengthen it by 1/2 step. So now instead of C, C sharp, D, D sharp, E, or 1, 2, 3, 4/2 steps, we're now going all the way to E sharp. So instead of 4/2 steps or 3/2 steps, now we have 5/2 steps in that interval. So we've taken the major third, which had 4/2 steps, and we have lengthened it by 1. Okay? So in this case, we're going up the chart and we're adding a 1/2 step each time, right? We would call that an augmented third. So hopefully this is starting to make sense. Basically, we define the perfect and the major intervals based on how many 1/2 steps they contain within the C major scale. And then if we just either shorten the interval or lengthen the interval by 1/2 step, we just move 1 step up or down on this chart. If we take a minor interval and we shorten it by 1/2 step, we get a diminished interval. And that rounds out the chart. Okay, so a major interval lengthened by 1/2 step gives an augmented interval. Shortened by 1/2 step gives a minor interval. Shortened by another 1/2 step gives a diminished interval. And you can just interconvert up and down this chart as much as you want. Now on this side, basically you can think of perfect as containing the major and minor inside of it. So if you lengthen a perfect interval by 1, you get an augmented interval. And if you shorten a perfect interval by 1, you get a diminished interval. And that's really all there is to it. So if you take a perfect fourth, let's erase our work down here again one more time. And let's do one more example with a perfect fourth. So, if I have a perfect fourth, I know that that's the same length as C to F. Okay? It's a fourth because there are 4 alphabetical steps, C, D, E, F. Okay? And it's a perfect fourth because it's the same length as the fourth that is contained in the C major scale. And what is that length chromatically? Well, we have a C sharp, a D sharp, an E, and finally an F. How many steps is that? 1, 2, 3, 4, 5. That's 5 half steps. 5 half steps. So, a perfect fourth could be defined as an alphabetical fourth that has 5 chromatic half steps within it. Now, what would happen if instead of the 5 half steps, and instead of the instead of C to F, what would happen if we shortened that interval by 1? And we can shorten it from either side. We can either flat this interval or we can sharp this interval. Either way, we're shortening the interval by a half step. So let's do it differently this time. Let's sharp this interval. So we're shortening the interval now from the lower side instead of the higher side. So now we've essentially just gotten rid of this, right? How many half steps do we have now? 1, 2, 3, 4 half steps. So we've shortened that interval by 1 half step. We've gone from a perfect fourth down to a diminished fourth. So the interval from C sharp to F is a diminished fourth. Okay? So I know this is probably a little bit confusing when you first see the concept, so let's just round this video off by doing a couple examples of naming intervals. Okay? So let's say we had an F to a B. Well, what kind of interval is that? Alphabetically, we have an F, G, A, B. There's 4 letters there, so we know that this is some type of fourth. Now, if we count the number of chromatic steps, we would go F, F sharp, G, G sharp, A sharp, and finally B. Okay? How many steps is that? 1, 2, 3, 4, 5, 6. Okay? So, if you recall from the last section of the video, a fourth that contains 5 chromatic half steps is called a perfect fourth. And that's just defined on the basis of the C major scale. So, this one has 6 half steps. So we've taken the perfect fourth and we've lengthened it by 1 half step. And if you can go back to the chart in the last section of the video, and you can see that if we lengthen an interval, a perfect interval of a fourth, by 1 half step, from 5 half steps to 6 half steps, we now have an augmented fourth. So the interval F to B is called an augmented fourth. Hopefully that helped, and I'll see you next time.